Today's lesson is going to talk about two more of the triangle congruence rules. So today we're going to be focusing on angle side angle, which is ASA for short, and angle angle side, which is AAS for short. So the first theorem says, hey, if you have two triangles with two sets of rainbows, which means congruent angles, so you would have two sets of these, 1 and 2, and a mark between those angles, then you can go ahead and say the triangles are congruent because of the ASA rule. Your tick mark would have to go here and here. So if you just look at both ends of your tick mark side, you need to have rainbows on both ends. So ASA is usually an easy theorem to do. AAS, that's a little stranger. So you still have two sets of angle markings. So maybe here and here, and right here and right here. You will have a tick mark that's not in between those angles. So before we put it right here, make angle side angle, but now we're going to put it outside of the rainbows. So the first one would go here, and then the second one would most likely go here. So hopefully you can see the difference between this set and this set. Here the tick mark is in the middle. Here the tick mark is outside of them. So in other words, it's not in the middle. So some examples of angle side angle. Again, you want to mark your own shared side and your own vertical angles, so those will not be provided. But I would mark both your angles for you. So that hopefully looks like angle side angle to both triangles. And then for the other one, I would have to maybe give you a rainbow here and here, but that means that I would also have to give you a tick mark here and here. So this is angle side angle. And the third one, you can mark wherever you want to put your rainbows in. Doesn't matter. But you got to put your tick mark in the middle of your rainbows. So again, we're going to do some non-examples of ASA so you know what is wrong. So hopefully you recognize these as wrong. So you put your own markings in for these pictures. And then everything else I would do. So I might put an angle here, but I might put one out here and put the other one right here. So in the triangle on the left, it looks like angle side angle, but the triangle on the right, it looks like angle angle side. So we would not say they're congruent because you don't have matching information. For this one, I might put a tick mark here and here, but I might put the rainbows here and here. So it definitely is a theorem. It's angle angle side, but it's not angle side angle. And then the last example, so again, we'll do something that messes kids up a lot, is we'll put two sets of rainbows. I'll put the tick mark in the correct place for one, but I'll put it in the wrong place for the other. So if you have this situation come up, you can't write angle side angle or angle angle side, you just write not congruent. So angle angle side would look like your own markings, of course. And then I would have to put rainbows maybe here, and then here and here. So the tick mark is not in between. For this one, I might put your tick marks right here and here, and then I might mark rainbows right here and here. So again, angle, angle, side. And then the third one, you could not put any of your own markings in here. I would have to put all the markings in. So I might put them here, here, and one right here, and one right here. So all of these are angle, angle, side. We're not going to do this part just because everything that's up here, I would just copy down to here. So these are all non-examples of angle, angle, side as well. So we're going to do a couple proofs really quick to make sure we can practice using the theorems. So after you copy your given, you do want to mark angles B and D as congruent. And then we know we're going to have to write definition bisect. And it says BD is bisected. So that means BD gets tick marks. So you have to write in your proof that side BC has a tick mark and so does CD. So they are equal. So far you have angle side. The last thing you have to get on your own, and hopefully you realize there's vertical angles right here and here. So you need to write in your proof that angle ACB is congruent to angle DCE. because they are vertical angles. And you don't need me to tell you vertical angles are congruent. And now I look at my picture, and now it looks like a theorem. It looks like angle side angle. So I can say the triangle ABC is congruent to triangle EDC because of angle side angle. So most of these proofs are only 4 to 5 steps long. They're not very long. The next one, it says Q and T are congruent in the given. So put rainbows at Q and T. It also says R is the midpoint of PS. So we want to write definition, midpoint. And I'm going to find PS and put tick marks. So I marked PR and RS. So far I have angle and a side, and hopefully you're picking up on the vertical angles so you can get that information yourself. Angle QRP is congruent to angle SRT, thanks to vertical angle rules. And now I look at my picture and I see 2 rainbows and a side. That means I have angle side in this case. So the triangle PQR is going to be congruent to triangle STR, all because of angle side. The last example says B and D are congruent, so you can go ahead and mark those. It says the top is parallel to the bottom, so you want to put an arrow for parallel, not a tick mark. So remember, this is not a tick. Right now you have an angle, and that's it. You have an angle for each triangle. But we did talk about in our last notes session that when you have parallel lines, you will be using alternate interior angles. And if you remember, your rainbows, your alternate interiors, have to touch the parallel side. So they have to be here and here. So they have to be between your parallel marking and your diagonal. So these are your alternate interior angles. So we want to go ahead and name them angle BAC and angle ACD. You want to go ahead and get the side that's in the middle. We did that last time. So AC equals itself, and that was the reflexive property. And now what I like to do is I don't need my parallel marks anymore. I like to erase those. And I'm going to put my tick mark on AC, like I said. And now I'm going to decide which theorem is it. And hopefully you can see if you look at just one triangle, either the bottom or the top, you have angle side. So the triangles are congruent. So triangle ABC is congruent to triangle CDA because of angle side. So we'll continue practicing these proofs, but that's basically how they usually run.